flare stars. In a star, there are some gases, and they're getting hotter because it is pressing together through its own gravitational constriction, because it's pressing onto itself, it's falling onto itself. It gets hotter. And when it gets a bit hot, then they're ionizing. And they're becoming plasma, these gases. They are losing an electron. They shatter apart. It's hot, but they shatter apart. Normally, atoms are neutral. They have the same amount of protons as electrons on the shells. They are neutral. Now they lost an electron. And now they have too much protons than electrons, so they are too positive. And they are no longer neutral, but they now a positive, or negative charge technically. A positive charge, no. And such a star is circling. And whenever something is circling which has an electrical charge, which it has because it's not positive, that has a magnetic field. Every current has a magnetic field. That thing has no magnetic field, such a star, a T Tauri star, a neutron star, or here flare stars. In flare stars, there accumulates this magnetic field, this force, this energy under the surface, typically near the sunspots. The sun has, but also these are the solar flares. So the energy is accumulating and then suddenly bursting out. All this magnetic energy is bursting out. And that has a lot of energy. It can be 6 septillion joules of energy. That is a very big number. Or 160 billion megatons. And it bursts suddenly out. One of these stars is UVCT. And if that thing has its flare episode, it gets 75 times as bright as usual. And it happens only in stars which are quite cool, so that it can accumulate. It's accumulating, they're not so hot, not so much radiating, they're quite cool, and then suddenly it bursts out. For example, Proxima Centauri, which is a red dwarf, so a bit slow burning star, and then suddenly it bursts out. And that is according to Mark A. Carnick's Cosmic Melancholy book on the page 56. Hi and welcome. I'm trying to learn helioscience today, flare stars. And after we've done it, we're going to do standing yoga. And if you participate in the standing yoga, then it's better to know. Flare stars. Astronomers frequently encounter magnetic fields which permeate the great gas clouds or nebulae throughout interstellar space. I don't really know what permeate means. I think it means something like going through it, but only from biochemistry, because they said that the lipid bilayer is permeable for some substances and non-permeable for other substances. That's all I know. Now, it permeates great gas clouds or nebula throughout interstellar space. There are some magnetic fields which are going through great gas clouds, nebulas, or through interstellar space. Most solar system planets have magnetic fields, and we have already encountered them in association with some stars, T Tauri stars and neutron stars. For example, that is because they hadn't gotten hot, and when they got hot, these gases in it were ionized, so they're breaking apart and they're losing an electron. And when they're losing an electron, they are no longer neutral. They have an electron less as they have protons in the center. They are not balanced anymore, and they have a charge because they're unbalanced. They're positive or negative. They are now charged, no longer neutral. And because it starts turning, it is now turning current, running current, and every running current has a magnetic field. And therefore, such a T Tauri star, neutron star, has a magnetic field. In a particular potent class of neutron stars known, quite frequently, as magnetas, the field strength is so intense that it could wipe credit cards and rip Catalay out of your hand. I don't know what Catalay is, and I don't know what strength is necessary to wipe out credit cards. From a distance of halfway to the moon. Yeah, I get that part. They mean to wipe out a credit card, one has to go very closely with a strong magnet. That thing could do it from a distance as from the moon. The so-called flares. How fast is a magnetic field? Is it instantaneously? How fast is gravity? Gravity can't be created, I think, so far. But how fast is a magnetic field? Is it able to transport messages with a magnetic field? Or is it not long enough? Is that the cause? Is it not? The distance is too big. Has someone, if it's the distance so long, has someone put some effort into it, finding out to make a specific form of magnetic field to make it possible to transmit messages over a long distance with a magnetic field. So-called flare stars, while not quite as extreme, are no less awesome. So we were talking about magnetas. So there are magnetas which are a class of neutron stars. I'm trying to sort all the stars, all the phases we had, and I'm thinking, if you have no magnetas as a special phase, that wouldn't be a phase of a neutron star. And how many phases are here left in this book, if it goes on a bit. So to what point does it make sense to call a phase of a star a part of a phase state, a part of a phase of a star's life? And at what point does it still make sense because it's an alternative phase, like with neutron stars and the white dwarfs? But when doesn't it make sense anymore with the magnetas? Okay, there are now the flare stars. Flare stars are those in which magnetic activity causes the stars to brighten suddenly with very violent bursts of energy. There is a magnetic activity, and suddenly the thing brightens and bursts out energy. Similar events take place on the Sun, solar flares. These occur when magnetic energy accumulates in the Sun's atmosphere and is suddenly released, usually close to the zones around sunspots. Solar flares are epic events releasing some 6 septillion joules of energy. This is a 6 followed by 25 zeros. Did you read it? Is it the first or second time we read it? To give some perspective, a solar flare, yes we did. A solar flare releases energy equivalent to around 160 billion megatons. Yet the Sun is a flare-sedate star. In proper flare stars, the magnetic fields are typically 1,000 times stronger than the Sun's. During a flare, the star jettisons vast quantities of subatomic particles into space at speeds approaching that of light, and the star's luminosity increases drastically. For example, a star called UV-CT emits up to 75 times its normal amount of light during a flare episode. The flaring phenomenon works only in relatively cool stars, yellow, orange, or red, and the overwhelming majority of them are red dwarfs. Most of them are red dwarfs. Indeed, the red dwarf Proxima Centauri is also a flare star. More recently, astronomers have discovered a flaring activity in star-like objects called brown dwarfs, which we will meet next. We did it in the last part of Heliology. Flare stars. I want to explain the thing of the magnetic field. In flare stars, they have suddenly such a magnetic field. I think they're building up. In a typical flare star, flaring occurs persistently. The process is abrupt and unpredictable, with each one lasting minutes or hours. Usually gigantic spots punctuate the toiling stellar surface of these stars. I think it builds up and then bursts out. It won't make a lot of sense. And then we're having a very violent burst of energy. We're having a strong magnetic activity, and we're suddenly brightened. The Sun, for example, has these solar flares as well. Magnetic energy accumulates in the Sun's atmosphere and then is suddenly released, usually by the sunspots. And they're releasing a lot of energy. Six septillion joules of energy, a 6 with 25 zeros. 6 septillion, 6 septillion. Or 160 billion megatons. And in flare stars, we are 1,000 times stronger. The luminosity increases drastically. One example is the UV-CT. UV-CT, emitting 75 amount its light in that flare episode. That works only in cool stars like red dwarfs, for example, Proxima Centauri. Okay, I want to start a second now. 6 septillion joules, 160 billion UVCT. And what is it? This is a magnetic activity cause of the stars to brighten suddenly with very final bursts of energy. How about we just try it and look what happens? Flare stars. In a star, there are some gases, and we're getting hotter because it is pressing together through its own gravitational constriction, because it's pressing onto itself, it's falling onto itself. It gets hotter. And when it gets a bit hot, then they're ionizing. And they're becoming plasma, these gases. They are losing an electron. They shatter apart. It's hot, but they shatter apart. Normally, atoms are neutral. They have the same amount of protons as electrons on the shells. They are neutral. Now they lost an electron. And now they have too much protons than electrons, so they are too positive. And they are no longer neutral, but they know a positive, negative charge technically. A positive charge, no. And such a star is circling. And whenever something is circling which has an electrical charge, which it has because it's not positive, that has a magnetic field. Every current has a magnetic field. And that thing has now a magnetic field, such as a star, a T Tauri star, a neutron star, or here flare stars. In flare stars, there accumulates this magnetic field, this force, this energy under the surface, typically near the sunspots. The sun has, but also these are the solar flares. So the energy is accumulating and then suddenly bursting out. All this magnetic energy is bursting out. And that has a lot of energy. It can be 6 septillion joules of energy. That is a very big number. Or 160 billion megatons. And it bursts suddenly out. One of these stars is UVCT. And if that thing has its flare episode, it gets 75 times as bright as usual. And it happens only in stars which are quite cool, so that it can accumulate. It's accumulating, they're not so hot, not so much radiating, they're quite cool, and then suddenly it bursts out. For example, Proxima Centauri, which is a red dwarf, so a bit slow burning star, and then suddenly it bursts out. And that is according to Mark A. Carnick's Cosmic Menagerie book on the page 56. And that was the helioscience part. If you were here for helioscience, look now directly to the next part of helioscience, where we will continue probably with the brown dwarfs, stars. And if you stay here and participate in the standing yoga, then it's better the Augenmask. The feet are sitting together, and we're breathing in and lifting the arms up. Out and down. In and up. In and up. Hold on to the side. In and up. Hold on to the other side. In and up. Out to the side, make an inch of space between your feet. In and up on the tiptoes. Without up onto the a bit down. In and up. Out and down. In and up. Out and down. In and up. Out and down and lean onto the knees. Really forgetting. And out, make a Hellwerfer back. In middle. Out the belly. In middle. Out hill. In middle. Out hill. In middle. Out, come with a round back up. Make at the top a big with shoulder round. Lift the arms up, come up onto tiptoes. Breathe out and down, feet together. Breathe in, bend the right leg. Breathe out, stretch your left leg. Even change. Out, stretch your right leg. Even change. Out the left one. In middle. Out the right one. In middle. And bow at the same time. Breathe in, lift the right hand up to the sky. Bend the left knee. Look to the sky, breathe out. Arm down. Breathe in, left arm up, bend the right knee. Look to the sky, breathe out. Inhale down. And out. Make a hand space between the feet. Shift the weight to the heels. Breathe in and come down. And breathe out and come up. In and down. Out and up. In and down. Out and up. Take hold of the elbows and gentle rock from side to side. Hands again out together. Breathe in halfway up, straight back. Out and down. In halfway up, straight back. Out and down. Breathe in, hands up. And again down. Have the toes pointing to the outside. Breathe in, the arms up. And breathe out and sink down. Hands against the insides of the knees. Breathe in, straighten up. And out and come with the back up. Slowly begin in. Out and down. Breathe in, straighten up. And out come slowly in one straight line upwards. Hands again down. Breathe in, arms up. And out, sink down. Breathe in, straighten up. Out come with the back up. Breathe in, straighten up. Out and down. Breathe in, straighten up. Out come in one straight line upwards. Hands again down. Have feet standing together. Breathe in, the arms up. Breathe out, lean back, draw the shoulder blades together. In and up. Out and back. In and up. Lean back with closed hands. In and up. Out, lean to the side. In and up. Out to the other side. In middle. Intertwine the fingers and reach high. Breathe out, reach in front, hold the back. In and up, intertwine the other. Out. In and up. Lean back with long arms. Draw shoulder blades together. Lift the arms down. In and up. Out and back. In and up. And back with long arms. In and up. Out with hands down. In and up. Out and down. In and up. Bring the hands to touch and lower them down to heart center. That was standing yoga. I thank you very much, and until next time.